So this is on the back of your starter. This is what we're going to label transformations, okay? So first of all, when we have transformations, there are three different types, okay? There's going to be one called a translation. And then let's give ourselves some room. And then there's one called a rotation. And then finally, there's one called a reflection. And we just want to be specific. It's always going to be a reflection this year over the y-axis. Okay, so we're only going to be talking about reflections over the y-axis. Okay, so first of all, translation. If I had to explain what a translation did, does anyone remember from the notes or just from last year in 8th grade math what a translation actually means? Rowan?
It means to change, to not change the slope, but change the y or x intercept.
Okay, so what are you actually doing then? So I'll give you a clue. The word starts with an S. S-L. Not slope. Nope. Slide. I think someone said slide. Slide. Okay, a translation is basically a slide. You're just sliding it over. Okay, you're moving it from the left to the right or up or down or diagonal. You're not flipping it. You're not turning it. You're not twisting it. You're just sliding it over. Okay, so that's what a translation is. Now let's talk about a rotation.
Wait, is this like things on the ground?
Yes.
Oh, I remember.
Yes. So you definitely talked about this last year in 8th grade math. And then these were your video notes. But we're not talking about shapes anymore. We're talking about lines. So we're just kind of changing it up a little bit, but with the same word. So rotation, if I rotate something, what am I actually doing to it?
It's like, if there's a straight line like this, and you rotate it 90 degrees.
So what is that called? What are you doing when you do that?
Turning it.
Turning it. So a rotation is a turn. And then finally, if we were to say a reflection,
It would turn
a flip. It'd be a flip. A rotation, or sorry, a reflection is a flip. Okay, so that's just to clarify. Translation means to slide. Rotation means to turn. Reflection means to flip. Okay, now before we even talk about, I guess, what these things mean, let's talk about something called a parent function. Okay, so a parent function, Emily, this is on the back side of your starter, okay? So a parent function is basically like the mommy and daddy, what it started off as, okay? Like the very basic, okay? So it'd be f of x equals x, that's the parent function. Or remember, f of x is the same thing as just saying y equals x. So that's also your parent function. You can write it either way, but notice how it just has an x there. There's no y-intercept. There's no like plus or minus 7 or 3 or 2 at the end. It's just the very basic. And remember, x is the same thing as saying how many x's? 1. So x is 1x, all right? So that's what you always start off with, 1x. So if you wanted to look at this, remember how we graph on a calculator? So you're going to go to y equals, and you're just going to go y equals and then x. And then the x button is right here, okay, guys? So if I want to look at a parent function, it basically just looks like this. This is what you always start off with. There's a slope of 1. It goes through the origin. That's what you start off with. That's the parent function, okay? Now let's talk about a translation. If we slide something, how do I know when something has been translated, rotated, or reflected? That's what we're going to talk about now, okay? So the way that you know that something has been translated is the rule is if you have a different y-intercept, but you have the same slope. So if something was a translation, that means your y-intercept changed because you just went up or down, but your slope is the same. You didn't tilt it any different way. So for example, let's say I have like y equals 3x plus 1. And then it got switched to y equals 3x plus 7. Notice how the slope stayed the same. It's still a 3 and a 3, but it's the y-intercept that changed. It went from 1 to 7. So I could say that if I had these two things, there was a translation that occurred. Do you know how many it translated?
7,
Not 7,
6.
6, because it went from 1 to 7. So you basically just subtract them, right? From 1 to 7, it went 6. It changed 6. Do you think it went up or down? Up, because it went from positive 1 to positive 7. So it went translated 6 up. So let me show you on the calculator what that really looks like. So you had 3x plus 1 and then 3x plus 7. Or actually here, let me show you this. 3x plus 1 looks like this. Okay, so that's what I started off with in this made up problem. Now, if I want to go 3x plus 7, you'll notice how, oh, I typed something wrong. 3x plus 7, there we go. You'll notice that it's still the same tilt. They're parallel to each other, right? All it did was move 6 units up, and that's how it translated. It just slid up, and that's it, okay? So that's the rule to be a translation. Now let's talk about a rotation then, okay? So if I have a rotation, the rule is that you have a different slope, because if it tilts a different way, then that means that it turned, but you have the same y-intercept. So, for example, let's say I have, and this time I'm going to write f of x, but remember, f of x is the same thing as just saying y equals. I'm just changing up to let you know that you can write it either way. F of x equals 6x plus 3. So that's my first original, let's say that's my original problem. But then I moved it, and now let's say I moved it to like g of x equals, okay, so the rule is I have a different slope but the same y-intercept. Does someone think they can make up a problem? Any numbers, different slope, same y-intercept to show that it rotated. Vaughn, what do you think? 2x plus 3. Great, right? Do you see how the slopes are different? It went from 6 to 2, but it had the same y-intercept, 3 and 3. That's how you know that there was a rotation there. So I would say this had a rotation of, do you know how much it rotated by? 4, right? Because from 6 to 2, there was a difference of 4. So 6 minus 2 equals 4. So there was a rotation of 4. Technically, I would say that it's a rotation of -4 because it went down, right? If you went up 4, then it would be from 6 to 10. But I'm not going to be that specific. I'm just going to say it rotated 4. Don't worry about the positive or negative of it. But technically, it is a -4 because it went down 4. Okay. Last one, a reflection. We said a reflection is flipping it. You're just flipping it. So the only thing that's different with a reflection is that the slope changes symbols. So like it changed from a positive to a negative, or it changed from a negative to a positive, but only the slope. So for example, let's say I have y equals -3x plus 1. How can I change this? Can someone raise their hand and tell us to make this into a reflection over the y-axis? The slope changes symbols, and that's it. What would that look like? Owen?
It'd be y equals negative, no, positive 3 plus.
3x plus 1. Good. Do you see how the slope was a -3 and now it's a positive 3? So my slope changed symbols, which means that I had a reflection over the y-axis. That's my rule.
Isn't there like a fourth one that like changes the shape?
Yes, that's called a dilation. And a dilation changes like the size, right? But if we're just talking about lines, you can't change the size of a line because the line is straight and it goes forever. So you would be talking more of like triangles, circles, whatever, stuff like that. But we're not doing that in algebra. Okay, So that's really the rule. I think that if you have this sheet handy, then it really tells you like, okay, was it a translation, a rotation, or a reflection? Those are the rules. So let's go to the front side. So let's compare here, okay? So they're telling me that I originally started with this, 2x minus 3, but then I turned into this. Wait, what? Like g of x equals f of x minus 4? So they actually want me to do a little bit of math here. They want me to say, okay, if f of x is 2x minus 3 and g of x, so I would say g of x is f of x. So what was f of x? F of x was 2x minus 3. So do you see what I did? I basically just took f of x and I just plugged in what f of x is. And then I have the minus 4 at the bottom. So let's clean that up. I have g of x equals 2x minus 7. Does that make sense how I got from like here to here? Because they told me to take f of x, which was this, and then subtract 4. So now that I know this, let's take a look at the rules, or let's see what changed maybe, and then take a look at the rules to see what happened. So look at your slopes. Did the slopes change? No. Did the y-intercept change? Yes. So look here. Which rule says that the slopes change, but the slopes stay the same? Translation, right? So we can say that this is a translation of how many units?
4.
4.
-4.
-4. So technically, because you went smaller, right? So you can say translation of -4, or you can say 4 down. -4 is the same thing as saying 4 down. Okay, so that would be my answer. This is me showing my work to get to my new answer. Okay, let's try the next one. I have f of x equals 3x. That's my first equation. And then I have g of x equals negative, and then whatever f of x was. F of x was 3x. So do you see what I just did? They told me to take f of x and then just stick a negative in front. So here's what I'm comparing. So maybe look at the back side, see what the rules are, see how this got changed. Emily, what do you think?
Reflection.
So the slope change symbol is a reflection. Do you see how my slope change symbol, 3 and -3? Good job, Emily. So this would be a reflection over y-axis. Okay, next one. So f of x equals -x plus 4, and then g of x, so I'm going to rewrite this, g of x equals 2 times f of x being -x plus 4. So here's my question. Should I multiply 2 with both of these things, the x and the 4, or just the x? The whole thing. Because you see how here it says 2 times all of f of x? So if it's 2 times all of f of x, that means that I have to multiply all of that by 2. So technically I have g of x equals -2x plus 8. Okay. Geez, a lot of things happened here. A lot of things changed. So does someone have one of the changes? Like you could have a reflection and a translation and a rotation all at the same time. You can't just you don't have to just have one. So can someone raise their hand and tell us one of the things that might have happened maybe? Kip, what do you think?
It was a reflection, and it was also a translation.
Okay, you're 50% right. It was definitely a translation. So Kip, it was a translation of how many?
+4.
So 4 up. That's one of the answers. But it was not a reflection, because reflection means you change symbols. You went from a negative to a negative, so it didn't change symbols. Reed, what do you think?
A rotation because the slope changed.
Yeah, because your slope changed. So Reed, if it's -x, what is the number here?
1.
Okay, so it's -1. So does anyone think they know it's a rotation of how many? Vaughn, what do you think? Yeah, so it's a rotation of, you can say -1 or you can just say 1. We're not gonna worry about the specifics because right now is your first time learning it. Technically, it is -1 though, right? Because you're going down, you're getting smaller. Okay, so let's do this last one then. This time it looks like I don't really have anything to like actually do math-wise. I just have f of x equals x, g of x equals 2x plus 3. So there's nothing to fix in this problem or rewrite. So I can tell you right now, definitely two things happened. Does anyone think they know what two things happened? Rowan?
Is translation and not reflection, rotation.
Okay, so definitely a translation because it looks like translation rules are different y-intercept. So yeah, my y-intercept's changed. Wait, Rowan, what is my y-intercept in this one?
There is y-intercept.
So if there is no y-intercept, what is the y-intercept?
0.
0. So technically, do you see how this is like f of x equals 1x plus 0? Okay, so Rowan, it was a translation of how many?
Plus 3.
So 3 up. And then Rowan, you also said it was a rotation. Good job. So let's be a little bit more specific. Rotation of how many?
It's a rotation of 2.
Not 2. You went from 1 to 2. So how many changed?
1.
1. So it's a rotation of 1. Okay. Number 5. Holy moly. All right. An internet service provider charges customers $80 per month for its service with no installation fee. The cost to a customer is represented by that, where M is the number of months of the service. To track new customers, the provider reduces the monthly fee to $60 with an installation fee of that. The cost of the new customer is represented by that, where M is the number of months in the service. Describe the transformation. So just do exactly what you did here. Describe what happened. So it looks like they gave me all of these extra words that I really don't care about. All I really care about are the two highlighted things, right? Because they're just saying, describe the transformation. How did I get from here to here? And that's it. I think they're trying to confuse you to throw you off the scent. They're also just trying to literally explain in words what they wrote. So someone that has not spoken yet, can you tell us one thing that happened? Louis?
There's a translation of negative.
Translation of, okay, so you're really, really close. You're looking at the wrong thing when you're saying translation. The translation is when you have a different y-intercept. So you have a translation of
25.
25 up or down. Yeah, because you're going from 0 to 25. Okay. What did you say? Yeah, so you also have a rotation of how many, Pip? -20. Technically, if you just figure out that 20 is the number, that's perfect. But yeah, technically it is -20, right? You went from 80 to 60, so you went smaller, so it's -20. Okay, so at this time, your level work looks a little bit different. Let me go grab a copy really quick on the blue counter. So your level work doesn't actually say level work on it. It says 3.7 review worksheet. And it has like a ton of graphs on it. So for those of you who are online, this is the one that I'm talking about. It looks like this, okay? It's also on Schoology. So please write your name on it first of all. Okay, so we already know, what are the rules? Translation, rotation, reflection. We just talked about that. Okay, I'm gonna do like the first 2 or 3 with you just so you know how to do this. And then we're gonna, and then you can do the rest by yourself, okay? So number 1, write and graph the equation of a parent function. Okay, parent function. What is it? Y equals x. Parent function is y equals x. You're always gonna just start with y equals x. Okay. Now, it says write it, so we did, and graph it. So you can graph it by hand or you can graph it on your calculator. Honestly, for me, I'm just going to graph it on my calculator. So I'm going to turn on my calculator. So guys, if you haven't grabbed one, go grab a calculator. Go, go, go. I'll wait for you. Remember, you have a specific number that you're going to use every day for the rest of the year. If you don't remember that number, I can tell you. But please grab your specific number.
I brought my good calculator.
Sure. You are
I
number,
think I'm like 13.
I don't know, let's see. Louise, 13, yeah, perfect. Oh, why is that up there? Okay, so what I want all of you to do first is clear your memory. We have not cleared our memories, and I haven't taught you guys. This is something I would normally do for like, I don't know, the first week of school, but we just haven't gotten there yet. Okay, so all of you, clear your memory. So turn on your calculator, clear your screen. And so whenever your calculator just does something really weird and you're like, what just happened? You can clear your memory back to default settings, okay? So you're gonna hit second. So at home, you can do this too. Second, and then the plus, and then the number 7, 1, 2. And then either your screen will say like RAM cleared, your memory is cleared, or it should say done or something like that. So second plus 7, 1, 2. 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 All right, now let's actually graph this. So y equals x. So y equals x. And remember the X button is just right here underneath mode. That's the X button. And then hit graph. That's what it looks like. Okay, this is what you cannot do. If you just go, okay, this line kind of looks like that, boom, that's my answer. No, no, no. When you graph a line in algebra, okay, well, technically in 8th grade math too, but I don't know if your teacher made you do this, you have to have at least 3 points, okay? So what I want you to do is hit second and then table, and now here's a bunch of points. I normally just choose the whole number ones, but these are all whole numbers. So here are my points I'm going to choose, and you can choose any 3. I'm just going to do the first 3, 0, 0, 1, 1, 2, 2. That's where you have to have your points. I want to see 3 distinct dots on your grid somewhere. It doesn't have to be these 3. It could be any 3. You could spread them out or whatever, but as long as they're accurate. And now what you're going to do is connect the dots and then make sure you have arrows going on both sides. For those of you who are very OCD and you do not like how your straight lines are not straight, you can always use the side of your calculator as a ruler. That's fine. Or just try to have a steady hand. All right, so that's number 1. Now, number 2, it says, now take the equation from number 1. So take this equation and write and graph an equation of a line who has been translated 3 units up. So this is a translation 3 units up. So take this thing and then write the new thing with a translation 3 units up. And it looks like translation means different y-intercept, same slope. Can someone raise their hand if they think they know what the new one looks like? All I'm doing is translation 3 units up. JC? Perfect. And if you really want to be specific, you can just say 1x plus 3. I mean, it doesn't matter. It's the same thing. Translation 3 units up means that I changed my y-intercept. It went from 0 to 3. So now what I'm going to do is I'm going to graph this. So I'm going to go back to y equals. How did I do what? The y equals is right here. Some of your buttons might have been rubbed off because these calculators are like, I don't know, 5 years old. But it says plus? Plus. Okay, so hit clear. Okay. So y equals, and then go x plus 3. And then so hit graph. This is what it looks like. But again, you're not just sketching it, right? You're going to the table and just grabbing 3 dots. So second, table, and grab any points you want to. I'm going to choose 0, 3, 1, 4, 2, 5. So you can choose any 3 that are on your grid, and you can up arrow, down arrow, whatever you want to do. And then connect. And that's my new picture. Okay, I'm going to do one more with you, just so you kind of get the gist. Now it says number 3. Now take the equation from number 2. So I'm forgetting about number 1. That doesn't exist. Now I'm taking this equation, and I'm going to write and graph the equation of a line that has been reflected over the y-axis. So maybe look at the rule. What does a reflection over the y-axis look like? And change the previous equation to make it look like a reflection over the y-axis. And if you don't want to look at your starter, you can always look at these 3 rules that I have on top. It's literally the same exact thing. So, someone different, can you raise your hand and tell us what this one looks like? Owen?
Y equals negative x plus 3.
Perfect. All you're doing is changing the symbol. So from a negative or from a positive 1, it goes to a negative 1. So it's negative 1x plus 3. So now what I'm going to do is I'm going to go back to my y equal, type in negative 1x plus 3. Remember, the negative is at the bottom. It's not a minus. Okay, negatives and minuses are different. The negative is right here at the bottom. Go graph. This is what it looks like. Oh, my line is going down now. Hit second and then table. And then take any 3 points. Any 3 points you want, but you have to have 3 dots on your picture. Okay, you have to have 3 dots somewhere on your picture. Connect it. And that's your line. Okay, so like for number 4, you take a look at number 3's equation and then change it. For number 5, you take a look at number 4's equation. So all of us, because we have the same exact worksheet with the same exact rules, should come out with the same answer. Okay, so what I want you to do is I want you to try the rest by yourself, and then I'll just check your answers. Okay, I have the answers on Schoology. They're right somewhere here. Answers back, answers front. Okay, maybe before you go on to the next one, you actually double check and you double check that you got that previous answer right. I would hate for you to like do it all and then get them all wrong because you made a silly mistake somewhere, because every question builds on itself. Okay, so that's what you're doing. That's your level work today. And then as soon as you finish, you can